1.3 Trigonomic Functions. The Pythagorean Theorem and the distance formula, trigonomic functions, and quadratical angles. Let x, y be a point other than the origin of the terminal side of angle theta in standard position. The distance from the point to the origin is represented by this picture. So we're saying we have a point that's not the origin. That's this point right here. It stands for x and y. The origin, if we can't remember, it's right there where everything converges. It's where everything meets. So we have the radius, x, and y. So what does that mean to us? So x, that's the horizontal distance. Horizontal distance is the x-axis. Your y, that's your vertical distance. And then your r, your radius, that is actually your hypotenuse. So if we're trying to figure out certain distances, certain lengths, hypotenuse, stuff like that, we do use the Pythagorean theorem. But something that you might remember from geometry. Sohcahtoa. We're going to use that. We use Sohcahtoa literally up until like one of the last things we talk about. Sohcahtoa is super duper duper important. So what is so, what is ka, what is toa? So the so part, that stands for sine theta equals opposite over hypotenuse. So opposite over hypotenuse is the same thing as y over r. Theta is where you're looking at. Basically, it's where you're standing if you were looking out at the triangle. So in this case, this right here is our theta. So that's why opposite is y, and the hypotenuse is always going to stand for the radius. Okay, let's talk about ka. Ka is cosine theta equals adjacent over hypotenuse. Adjacent over hypotenuse is the same thing as x over r. I know you have all this in the table to the left. I know this. I know you have this on your table, but I like you to write it so it starts to sink in a little bit better. And then we have the toa. So toa, that stands for tangent theta equals opposite over adjacent. So opposite over adjacent, that's y over x. So that's how we find our missing sides or certain values. We use either x or y or opposite adjacent hypotenuse. Of course, this is all in this table. So you have sine, cosine, tangent. That's supposed to say tangent. I don't know, that was a typo. And then we have reciprocals of those. Remember, reciprocal is just flipped. So the reciprocal of sine is cosecant. And you see how it's just flipped? Everything is literally just flipped. The opposite of cosine is secant. The opposite of tangent is cotangent. So if you have sine, you can find cosecant. If you have cosine, you can find secant. If you have tangent, you can find cotangent because you just flip those values. So let's actually use this. We're going to find function values. So the terminal side of an angle theta is in standard position, passes through the point 815. Find the values of the 6 trigonomic functions of angle theta. So we're actually given the values. We're given that x is 8, y is 15, and r is 17. So remember, x is left and right, y is up and down, and r is always your radius, aka hypotenuse. So it's asking us to find all of the functions. So we're trying to find sine theta, and then the opposite of sine is cosecant. Then we need to find cosine theta, and then the opposite of cosine is secant. Then we have tangent, and the opposite of tangent is cotangent. All right, so we have the 6 trigonomic functions now. Now we just need to fill them out. So sine represents y over r. So if I'm at theta, I am at the theta right here. So I am looking out. I am looking out to my triangle. So basically it's something like you're standing right here and you're looking out at the triangle. So the y value of this triangle is 15. The r value of this triangle is 17. Also known as opposite over hypotenuse. It's also known as opposite over hypotenuse. So opposite the theta is 15. The hypotenuse is 17. So we can think of it two ways. Both ways are great ways to think about it. You should be thinking of it as x, y, and r and opposite adjacent hypotenuse. So for cosecant, since cosecant is literally the opposite, it's the reciprocal, which is just r over y, or h over o, we just flip the number we have for sine. So it'd be 17 over 15. So hypotenuse is 17 and opposite is 15. All right, so for cosine, that's where we have x over r. And then that's the part, so that's the same thing as adjacent over hypotenuse. So if we think of it as x over r, so the x value is 8, and the r value is 17. Or if we think of it as adjacent and hypotenuse, so adjacent is right, the one next to it that's not opposite, so that's why it's 8, and then hypotenuse is just the hypotenuse, 17. Since secant is the literal reciprocal of cosine, so the literal reciprocal means r over x or h over a, we just flip what we have, so 17 over 8. So I think that you can pause this and try tangent and cotangent. So I really want you to try it. Go ahead, pause it. Okay, I hope you did it. I hope you tried. Remember, my thing is no one can see you, so please try. So let's do this together. So tangent. Tangent is y over x. So I'm trying to get the triangle in there. It's also known as OA, the TOA part. So it's also known as opposite over adjacent. So if we look, the y value is 15 and the adjacent value is 8. So the y value is 15 and the adjacent value is 8. So, sorry, the x value. Or you can think of it as opposite adjacent. So opposite is 15, adjacent is 8. Y over x, 15 over 8. Cotangent is the literal reciprocal. So it's x over y, which is a over o, which is just 8 over 15. So we have our 6 trigonomic values. Okay, we're about to do this again. The terminal side of angle theta in standard position passes through the point -3, -4. Find the value of the 6 trigonomic functions of theta. So this is where I really suggest that you pause the video and try it all on your own. But before you pause it, I just want to put a little asterisk in here, something that we should always think of. If you are missing a side, so if you are only missing one side, if you are missing one side with a right triangle, you can use the Pythagorean theorem to find it. So just keep that in mind. If you're missing a side, use the Pythagorean theorem. Okay, now I want you to go ahead and pause it and do the 6 trigonomic functions. All right, I hope you tried it. So we have sine theta. The reciprocal of sine is cosecant theta. And then we have cosine theta, and the opposite of cosine is secant. Then we have tangent theta, and the opposite of tangent is cotangent. If you write it like this every time, sine, cosecant, cosine, secant, tangent, cotangent, you'll have the reciprocals memorized. Okay, so let's do sine theta. So sine theta, we can think of it if you want to, you can think of it as y over r. Or you can use Sohcahtoa, which is easier to remember. So you could also think of it as the O over H. So let's do it both ways. So we're right here. We're at this point right here, and we're looking out. So the y value is -4. And the radius is 5. If we did it using Sohcahtoa, so we're standing right here. Opposite is -4, and the hypotenuse is 5. Now for cosecant, since it's the literal reciprocal, we just flip it. So it'll be 5 over -4. Where the negative goes, it's up to you. It's up to you. 5 over -4 is the same thing as -5 over 4, and that's the same thing as -5 over 4. Those all mean the same thing. But what I do is just keep it the way it is. I keep it exactly the way it is and don't mess with it. All right, so for cosine, we could think of it two ways. We could think of it as x over r, or the so adjacent over hypotenuse. So x over r, it would be -3 over 5. If we use Sohcahtoa, adjacent is -3 and hypotenuse is 5. Since secant is the literal reciprocal, we just flip it. And that's it. So for tangent is the same thing as y over x. It's also the same thing as OA, O over A. So if we did it just using Sohcahtoa, so opposite the theta, we have -4, and adjacent, we have -3. So we have -4 over -3, which can be simplified. It's not even supposed to, I'm never ever going to tell you to simplify. No one's ever going to tell you to simplify anymore. You just need to simplify. That is just the rule of math. Since college algebra, you need to simplify. So we can simplify this into 4 over 3. And then since cotangent is the literal opposite, it's 3 over 4. So now we're using Sohcahtoa. Hopefully it's starting to make sense, because I remember when I was in geometry, it didn't really make sense. But hopefully now it's like, oh, I finally get Sohcahtoa. Hopefully, that's my goal. Hopefully by the end of your homework, that's the goal. Okay, let's use Sohcahtoa in a different way. So let's find the 6 trigonomic function values of the angle theta in standard position if the terminal side of theta is defined by x plus 2y equals 0 when x is greater than 0. So I'm just going to bring this out. We have x plus 2y equals 0. Now that is a line. How do I know it's a line? It's just x and y. There's no other variables, it's just x and y. That's how I know it's a line. So whenever we have a line, let's solve for y. That's usually our goal, is to solve for y, because we're not given the angle here. We're saying that theta, which is the angle, is defined by this line. So the angle is x plus 2y equals 0, but I don't know what the heck that is, so let's solve for y. So we subtract x, we have 2y equals -x. Divide by 2, we have y equals -1/2 x. So now we have our line. So we start at 0, 0, and then we go down 1, right 2. And we have our point. So now we have our theta. This is our theta right here. That's our theta. That's our angle. So now we need to fill out the rest of this triangle. So we have this point right here, this point, we have that point. This point represents 2, -1. So if I bring this out, we have 2, -1, that's x and y. So x is left and right, so this is 2, and then y is up and down, so this is -1. So we have x and y, all we're missing is the hypotenuse. So to find the hypotenuse, we just use the Pythagorean theorem. So we need to find the hypotenuse, aka the radius. So we're going to use the Pythagorean theorem. Now the Pythagorean theorem is a squared plus b squared equals c squared. So let's go ahead and plug it in. We need our hypotenuse. We don't know what it is. So our legs are interchangeable. So our first leg we could say is, so our legs are 2 and -1. It doesn't matter what the leg is. The only important thing is the hypotenuse, which we don't have. So we have our legs. So we have 2 squared plus -1 squared equals the hypotenuse. So we have 4 plus 1 equals the hypotenuse squared. You could also change that to r squared. It doesn't matter. So we have 5 equals r squared. You could change it because we know the hypotenuse is actually r. We take the square root. So we have the square root of 5 equals r. Now you're like, but you took the square root. It should be positive, negative. It's not positive, negative. It is only positive. You only take positive square roots because we're talking about distance. So only positive radicals because we're talking distance. R in your hypotenuse, that's always going to be positive. Okay, so now we have all of our values. We found this. We found it. It's the square root of 5. So now that we have all of our values, we could start to do Sohcahtoa. All right, now that we have all the sides, we can go ahead and use Sohcahtoa. So the first thing we're going to find is the sine function. So we have sine theta. So sine, remember that's opposite over hypotenuse. So another way we can think of opposite over hypotenuse, we could think of that as y over r. So if we do opposite over hypotenuse, opposite the theta is -1, and the hypotenuse is square root of 5. Now we have to simplify this because we're not allowed to have square roots in the bottom, so we rationalize square root of 5, square root of 5, and we're left with negative square root of 5 over 5. So that's what our sine theta represents. Now we need to find our cosecant theta. So remember, cosecant is the literal opposite. So literal opposite, you could either flip this one or you can flip this one. Now, when we're working with radicals, I'm going to flip the one before I rationalize the denominator. You'll see why I flip this one. So I'm going to flip this one right here. I'm going to flip that one, and I'll tell you why. So when we flip it, we have square root of 5 over -1, which is just negative square root of 5. See how easy that was to simplify? If I flipped this one, we would have 5 over negative square root of 5, which you would have had to rationalize. That's a lot more work. So when you're working with radicals, pay attention to what you can flip. You could flip this one, you can flip this one. Both are going to give you the right answer. Okay. So now that we did cosecant, what's next? What's after cosecant? Say it to yourself. Go ahead, say it to yourself. What is it? It's cosine. We have cosine, and then what's the reciprocal of cosine? Say it. I want you to say it to yourself. I know. Do it like what's it called? Dora the Explorer. Dora the Explorer, right? When I'm talking to you, you talk back. Trust me, I know it's stupid, but it really works. It's like little stuff like that. Yeah, it is totally lame, but it works, and I'm lame, so it works for me. All right, so we did sine, we did cosecant. Let's go ahead and do cosine. So we have cosine theta, and then what's the reciprocal of cosine? Secant. All right, so cosine, we can think of that as x over r. aka the c part, so a over h, adjacent over hypotenuse. So x is 2, and then our r is square root of 5. So we have to rationalize our denominator, so times square root of 5 times square root of 5. So we have 2 square root of 5 over 5. So that is our cosine. Now what we can do to find secant is just literally flip it. Now I'm not going to flip this one because we have radicals. I'm going to flip the one before we rationalize. So I'm going to flip this one right here. So we have square root of 5 over 2. That's simplified. It's rational. We're all good to go. Sweet. Last but not least, we have tangent to worry about. So we have tangent theta, and then what's the opposite of tangent? Cotangent. That one's easy to remember because they actually go together. It makes sense why they go together. All right, so tangent, we can think of that as OA, or y over x, which is just OA, O over A. So tangent y over x. So if we look at our triangle, we have y, which is -1, x, which is 2. So -1 over 2. That's rationalized, we're good to go. Then we have our cotangent, so you just literally flip it. So we have 2 over -1, which is just -2. So we have our 6 trigonomic functions. All right, example 4. Finding function values of quadratic angles. Find the value of the 6 trigonomic function values for an angle of 90 degrees. So it's supposed to be blocked out here. You're not supposed to see this. I meant to erase this, but I'm going to show you how we got this. So we have a 90-degree angle, which looks like this. That's what a 90-degree angle looks like. So because we're talking about the unit circle here, we haven't really touched on that yet, but all trigonomic values fall between an interval of -1 to 1. But since we're talking about a 90-degree angle, we're only working with in quadrant 1. So a 90-degree angle tells me that we're working in quadrant 1. And trigonometry, our unit circle is exclusive to -1 and 1, x and y, for the domain and range. But since we're in quadrant 1, we only are working with the positive numbers. So in quadrant 1, x is always going to be 0 and y is going to be 1 for a 90-degree angle. So we have x, we have y. What's missing? We're missing the radius. We're missing this part right here. We're missing the radius. So we have to find it using the Pythagorean theorem. So using the Pythagorean theorem, we have leg squared plus leg squared equals hypotenuse squared. I don't know why I have to write it that way. I do not write in cursive. I do not like cursive, but I have to write this in cursive because that's how I've always seen it in my life. Anyways, so our legs are what we have because we're trying to find the hypotenuse. That's what we don't have. We don't have the radius. So we have 0 squared plus 1 squared equals radius squared. So we have 1 equals radius squared. We take the square root. So we have 1 equals the radius. So we found this value, it's 1. So now we have our radius, it's 1. Now that we have everything, we can go ahead and do our Sohcahtoa and all the reciprocals. So this is where I highly suggest you pause the video and try it. Try it, okay? I hope you did. I hope you tried it. It's okay if you didn't. I can't force you, but I really would like you. So let's go ahead and find sine theta. And then what's the opposite of sine? What's the opposite of sine? Say it again. Cosecant. It is cosecant. And then we have to find, I have to do it over here. We have to find cosine theta. And then what's the opposite of cosine? Say it with me. What's the opposite of cosine? Secant. And then we have the easy one. We have the easy one, tangent. And then opposite of tangent is cotangent. I'm going to do it over here. All right, so just like before, we're going to break it down between sine or x and y, o and h and stuff like that. So sine theta is y over r, also known as opposite over hypotenuse. So if we're looking at theta, we're at theta right here. Opposite, it's hard to tell, right? It's hard to tell what's the opposite angle there. You would think 1. You would think 1 is the opposite, but it's not. So you see how knowing y and r and x is actually kind of important here because it's hard to tell what other values I'm even working with. So I'm just going to use y, x, and r here. So y represents 1, r represents 1, so 1 over 1, we get 1. So then the direct opposite, the reciprocal of 1, is just 1. So that's our cosecant. So we found cosecant and we found our sine. Now we're going to do the same thing for cosine theta. So cosine theta, which is x over r, aka so adjacent over hypotenuse. But again, it's hard to tell what's the adjacent and what's the the hypotenuse we get, we can see it's 1, but it's hard to tell what the adjacent is. So what we do is use x over r. So x is 0, r is 1, and 0 over 1 is 0. Now for secant, we have to flip it. So the reciprocal of 0 over 1 is 1 over 0. You are not allowed to have 0 in the denominator, so it's undefined. All right, so for tangent, that's y over x, also known as O over A. But again, we can't really use O over A because that doesn't really make sense for quadratic angles, so we use y over x. So y is 1, x is 0, which stands for undefined because 0 is in the denominator. Now for cotangent, cotangent is just the reciprocal of tangent. So the reciprocal of tangent is 0 over 1, which is 0. If you can never remember undefined and 0, use your calculator. If it's undefined, it'll say error. It'll literally give you an error. If it's 0, it'll say 0. Conditions for undefined function values. If the terminal side of a quadratic angle lies on the y-axis, then the tangent and secant functions are undefined. If the terminal side of a quadratic angle lies along the x-axis, then the cotangent and cosecant functions are undefined. So, do you need to memorize that? Absolutely not, because you could just do Sohcahtoa, right? You could, but it doesn't hurt to just know that information, that if it's on the y-axis, tangent and secant is undefined, and if it's on the x-axis, cotangent and cosecant are undefined. But you don't need to know that. You could just do Sohcahtoa. Here is this nifty little chart that you could also use and memorize. Now, you can't use this for the test, but you could use it for your homework to help you. So, these are quadratic angles, 0, 90, 180, 270, 360, and it tells you all the values for which they're undefined. So do you notice sine and cosine are always going to be a number? So sine and cosine, no matter where you're at for a quadratic angle, you could be on the x-axis or y-axis, it's always going to have a value. It's tangent, cotangent, secant, and cosecant that have undefined values. Function value, so using a calculator, function values of quadratic angles can be found with a calculator that has trigonomic function keys. Make sure the calculator is set in degree mode because we're talking about degrees here, not radians. So how to get degree mode? On your calculator, hit mode. It's like in the top middle part, and then you would switch it over to degree, and then make sure you hit enter. So when you highlight degree, make sure you hit enter. One of the most common errors involving calculators in trigonometry occur when the calculator is set for radian measures rather than degree measure. Be sure you know how to set your calculator in degree mode. All right, so how could we use this how could we use a calculator to find quadratic angle values? So make sure you hit mode, and if it's not in degree, highlight it and press enter. Mine is already in degree. So once you're in there, hit second mode. It'll bring you back to the home screen. So see here how it says sine, cosine, tangent, and then sine -1, cosine -1, tangent -1. Those blue things are not the reciprocals. Sine to the -1, that is not cosecant. That is the inverse sine. Cosine to the -1, that's inverse cosine. Inverse and reciprocals are not the same thing. So you cannot do the little blue sine, the little blue cosine, the little blue tangent. That has nothing to do with cosecant, secant, and cotangent. So do not use those buttons. So we can find sine theta by using our calculator. We're in degree mode, so our theta is 90 degrees. That was the value because it's angle. Angle of 90 degrees means theta is 90 degrees. So what we're finding is sine 90 degrees. So it's already in degree mode. We just have to put 90. And you see how we get 1? We get 1. So with cosecant, since there's nothing on your calculator yet and you don't know how to find cosecant because you haven't learned that yet, you haven't learned how to use your calculator to find cosecant, we would just take the reciprocal of that in our head or on the paper. The reciprocal of 1 is 1. So if we did something that was undefined, let's do tangent. So let's do tangent theta. So we have tangent 90 degrees. And you see how we get error? That's because they are not allowed. It's not a real number. It doesn't exist. So that's why it's undefined. So we know that undefined is 1 over 0. So the reciprocal of that would be 0 over 1, and that's how we would get cotangent. So you see how you could use your calculator? It really just depends on how you work. Honestly, I never use my calculator to find quadratic angles. I just work it out. It's longer, yes, but that's how I like to do it.